Welcome back, everyone. It's after the lunch hour, and I'm here with Art DeLeon, who's Deputy Director of the Navy Spectrum Strategic Policy Division, or department, or how do you like to refer to it?
It's more of a directorate.
Directorate. And we've had the Navy here repeatedly over the years, and we're pleased as punch to have Art here, as he is, I guess, by default with Tom Kidd's retirement, handling quite a few issues, including a lot of issues you guys heard about last year. So I'll turn it over to Art, and we're pleased to have you here and love to hear what the latest developments are.
Thanks, Joe, and I appreciate the opportunity to come speak to the National Spectrum Management Association. I know this is a huge deal when I look at all the personnel that were speaking yesterday and today. I think it's a great opportunity, and I can't go away without recognizing Tom Kidd for his 44 years of federal service, and 17 of which he spent within the Department of Navy. I think that's some key components when I look at, he was a key enabler to strategic spectrum policy and vision within the Department of Navy. And I have to recognize one of the items that I would say that he always looked at his employees or his personnel or his team. I guess team is probably the appropriate word, is always looking outside the box and looking for the future change. And the key context that used to be one of his #1 challenges is this is the way we always used to do it. And his key word doesn't mean it's right, and it doesn't mean that we can't improve on it. And that was one of the challenges that he always would tell us. If you hear that, let's really peel back the layers and understand what it is before we move forward. But overall, I'd like to give a quick overview on spectrum modernization and some of the key items that Tom talked about last year, and look at how do we move on to the next step. So opening up spectrum modernization. I know this is one of the key elements that's probably near and dear to everybody's heart. And that foundation of what is spectrum modernization and some of the key aspects. I look at it from the key component is today, that static spectrum management process is completely outdated and won't support tomorrow's technologies. If I can correlate it to an IT term, it's under the same premise, data at rest. And I'll correlate it to spectrum at rest. If we continue to operate with the technologies that we're developing today with spectrum at rest, we'll never have the bandwidth to support tomorrow's technology. So those key attributes that are needed to support those future capabilities must eliminate those concepts of data at rest. How do we make those ties and ensure that we collaborate in order to meet the intent of where we're going as a federal government and industry? I think those are some of the key aspects of what we have to develop and work together and collaborate to make the best of finite resource that we have available to us. And I guess the best way I like to describe it and put it to context, if we understand that the federal government has 1.4% of exclusive spectrum remaining, and industry has about 5.6% of exclusive spectrum, and that's the allocatable spectrum that we typically manage, 0 to 300,000 megahertz. That tells us that the challenge is really on the rise, and there's not a lot of wiggle room as we move forward. And I hear scheduling as the new capability, as how do we gauge and share more appropriately, and scheduling is the next step. And I'm here to tell you, we've been scheduling for the last 30 years within the Department of Navy, and we have that down to a fine art, and we do it with very limited spectrum already. I think the next piece is how do we look at dynamic spectrum access, agile type software, and some key capabilities as we move forward. But that foundation alone is, where do we go from here? I know from a Department of Defense standpoint, we used to lead cutting edge technology, but that cutting edge technology is likely still being developed within the research and development department. But we don't have a great path on how we transition that research and development into a program of record, which makes it a reality for some of those wideband capabilities that we need in the future. What I have found, and looking across technology, is now it's industry leading that key technology and providing that high bandwidth requirements as we start to move forward. So how do we look at it? What's some of the key context, and how do we develop and move forward? I believe the only piece we could say is we're looking at the strategy. What is the strategy and how do we get there? How do we transform and become a modern federal organization in line with industry and where we're going? Modernizing our spectrum management components is the next evolution of technology. And I know this is one of the key items that Tom has always talked about, is I'm trying to replace our responsibility from a spectrum management standpoint. And I agree. The key context is how do we develop agile software and type capabilities to minimize those discrete frequency assignment processes that are outdated? How do we transform and ensure that we're modernizing our key capabilities? If we consider not only where the Department of Defense is going, the federal government, and where industry is going, we're after some of the same platforms, and understanding the intersection between the federal government and the Department of Defense is key. We're all after the same component, and the only way we're going to get there is if we work together. And I like to call this the spectrum management Apollo mission. When you consider that, what is some of the key attributes that we look at? Autonomous vehicles, high data throughput architectures, unmanned systems. If you look at integration of unmanned systems to national airspace, those are just some key aspects as we start to move forward and develop these key components. But how do we get there? We have to have a clear strategy and roadmap. And I know the Department of Navy is in the process of developing that strategy and roadmap. And I would be interested from hearing from the community and how we get there together, just because when I see this as a federal government problem, I see this as a federal industry problem, because we're after the same bandwidth. And if we don't get there together, then it'll be cumbersome and we'll have the same problem as we move forward. So transformation. The key question, are we ready for transformation? And I know this is one of the items that we look at across the board. What is transformation to us? It starts with the culture. And if you consider the culture, this is one of our #1 problems. How do you change the mind of a paradigm that has always looked at it from the context of this is my spectrum and this is your spectrum? And I think that's the foundation. And it also ties to our policies as we're moving forward and walking through the processes. So what does it mean from a culture standpoint? The best description I can give or a correlation is the old concepts of fiber optics end to end. And as we started to develop and we started to figure out what fiber optic end to end really meant, it meant that we hit some type of copper endpoint, which created a bottleneck. And for that culture to change, we have to ensure that we understand and are prepared to move forward. But looking at that culture establishes a requirement to review our policies end to end. And what does that mean? Understanding the culture as it walks through and looks at the entire policy. One of our #1 problems, and Tom was a great leader in evaluating the end-to-end type policies, which led him to streamline the broadband process for allowing different organizations onto the installations. So with that foundation, I think kind of paves the way of how we look at policy and understanding that end-to-end policy review process. That's important, because it doesn't matter if we change the policy at the lowest level that has to really operate under that policy is still doing business as he always has, then it eliminates the purpose of having that policy. And we recreate that bottleneck that's been existing in quite some time. So transformation is that regulatory concept of evaluating our policies. And I would tie that to some of our legislation. When we talk about spectrum location fund and a lot of the key concepts as it relates to that, and I heard that was one of the, or heard the topic this morning on how we're moving and trying to reestablish the spectrum location fund requirement to auction that's expiring this September. I would say the legislation, the way it was built into the Commercial Spectrum Enhancement Act, really didn't allow or account for how we move forward from a future standpoint and allowing technology to support where we're going in the future. That technology is being streamlined from the context that we can only develop to the current capability. So anything above and beyond that maybe can be improved slightly from a bandwidth standpoint and capability, but it doesn't really allow you to prepare to how we share better or provide better capabilities unless it's a sharing capability that we're building within that construct. But incremental approaches doesn't allow you to really change that piece of equipment to better share or utilize the spectrum from a wideband approach. So this strategy, how do we understand, how do we leverage these multi-band capabilities that are resident already in today's cellular technology? That's the key concept. How do we get there? What's the strategy? Multi-band capabilities that are developed and operating within that 5G construct is essential to moving forward. And believe me, if I look at the history of how the DoD has moved forward from 1990s technology that was still there, Vietnam era type radios, we're talking PRIC 125s or PRIC 25s or PRIC 77s, which is a VHF radio, and we used to dream that we would have a multi-band type radio. But that turned out to be as an integration of VHF and UHF type radios. And then I look at where we are with cellular technology, and we have a mobile computer at our fingertips. That foundation by itself is starting to talk how that multi-band platform is really building for our future. How do we get there, and how do we get there as an organization? And I know that our economy depends on us working together to get there. So that Apollo mission of Spectrum, the only way we get there, we got to the moon together. Now we have to get to ensuring that we're the economy of choice when we look at Spectrum and build our capabilities to look at the future multi-band type capabilities that integrates all our platforms. Now I can't walk away without talking about the workforce, because the workforce is essential to ensuring that we're successful at building this technology to support our future requirements. That workforce either is going to stay the same or be affected by that disruptive technology. And one of the key attributes that you always run into, if you feel like you're getting replaced with some type of technology, it creates a lot of friction internal to the workforce, and also causes people to leave unless you're planning and really working with that workforce to build a better workforce to support that technology as we move forward. So we can't go and build this 5G and 6G technology. And this also is essential to working with academia as we start to move forward and build those key components too. How do we look at those slicing or that future O-RAN capability and integrate it into our future radio systems? From a Department of Defense standpoint or Department of Navy, what I see is changing our radios is very expensive. And that foundation is how do we build that integration and interface as we build that old technology into the new technology. Those interfaces are going to be essential to how we develop that future capability. So it's important that we explain those key implications to our workforce and understand what those components will be. Now, I put this slide up not really to talk about the context of the auctions, but when you look across the many auctions that have already occurred, I think the key piece to this is understanding what each one of those means from a technology standpoint. And I like to look at it from the evolution of technology. The evolution of technology, and we can start by talking about the legislation that started from OBRA 98 that led to our first AWS-1 auction. And if I remember right, we're talking about the Motorola bricks that we always utilized back then, those big handheld phones. And I know, looking at the audience that we were speaking to earlier, some of us used them, and which is ironic. And then you look at what our kids are using today. It took quite some time to move from that Motorola concept down to that flip phone, now to our smartphone. And I have to be honest, my flip phone was the best thing since sliced bread. And I didn't want to go to that smartphone. My kids had to force me to go that direction. But what does that really mean? That's transformation. And I don't think we quite understand what it means to us from a spectrum management standpoint, and some of the things that we have to do from a building block standpoint. that Commercial Spectrum Enhancement Act, if we look at how it was developed based on that transformation of that 1950s technology as we get into our early 2000 type capabilities. And it really took us into the 2015 timeline. But what we're talking about today is 5G, 6G, and how do we leverage it from a government industry standpoint and ensure that we build the best capability to be the economy of choice. Now, from a Commercial Spectrum Enhancement Act standpoint, I know that was some of the key aspects of how we move forward, but how does it prepare us for the future is the key question. And how do we work together to ensure that we plan what the US economy is going to do from a federal government standpoint and an industry standpoint. And believe me, the utilization of spectrum, the discrete frequency assignment process, I was a user and abuser of that context. And we used to use discrete frequencies to maximize how we share spectrum across the battlefield and across our military installations. That's a huge transformation for the entire Department of Defense. And I don't know how many of you have read Who Moved My Chief? That was a book that was required for us to read as young Marines. And I tell you, change is hard. And getting the federal government to move to better utilization of that spectrum is going to be a hard task. But if we work together, I think we have a great plan ahead of us. And it's going to really take work, especially when you consider radar operations and capabilities, which is the current challenge within the mid-band operations. And I know we're not going to get there if we try to isolate ourselves and work in our own little circles. So I look forward to doing more collaboration as an organization as we start to move this forward. But as I stated earlier, none of this works unless we understand the intersection between industry and the federal government and the one key item that we're all after. The one item that we're all after is high bandwidth architectures. And those high bandwidth architectures need multi-band type capabilities. And those multi-band capabilities built into our infrastructure and all our data networks across the entire United States. How do we get there? What's the plan? What's the strategy? And I think it's going to take a strategy, not only from a federal government standpoint, but an industry partnership as we start to walk this forward. Next slide. I think we went up one. Now, roadmap to spectrum modernization. I believe this is one of the key elements I like to, and I think this this graphic is very fitting because the Commercial Spectrum Enhancement Act was a foundation that allowed us to really see that transformation within the telecommunication world. And I'll tell you, that change was very difficult for the federal government because we're used to having our primacy within the spectrum world and be able to operate, but that has changed drastically and we realize that. But the key aspect is we could choose to move forward as that wheel spins. And that's why I think this is a very important element. If the gear spins forward, we're moving forward and we're transforming. But if we move back, we're defeating the purpose of everything that we've developed in the past. And it's important that we work together to come up with some of those key aspects. The hard part is how do we leverage that disruptive technology and ensure that we're modernizing some of our spectrum policies to support those future capabilities. From that aspect alone, I could tie some of our policies that have really impeded our ability to move forward because we have utilized discrete frequency assignment processes and minimized our wideband type capabilities. And I would say some of our federal policies follow that same construct. Reviewing those policies end to end and establishing an ability to start developing a roadmap and how do we improve those components is essential to us collaborating and working together to get to that wideband type construct. So leveraging disruptive technology is the foundation of how we move forward. And it must be under the premise that we're working together. And I have to just reiterate, 1.4% of federal exclusive spectrum and 5.6% of commercial exclusive spectrum. It's a telltale sign that spectrum reallocation is no longer a key capability that we can go after, and spectrum sharing is going to be the new norm. So with that, I know I'm looking at the audience. Of course, I could hear, well, I just want more of that 1.4%. And I would say from a federal government standpoint, I would say that we want to share more of that 5.6%, because how we get there is together. And I think that's some of the key aspects. Next slide. So politically, we know that we must lead the world in 5G technology to be the economy of choice. That foundation is essential for us moving forward, but along the way, how we secure our communications and protect our innovation as we go along. And I know that we've all been on the back end of some of those security issues and losses of innovation. In order for us to lead the country, we have to build those capabilities into our future components, ensure that we're addressing security and the ability to protect our innovation. And that we can't go against that alone. The only way we succeed at being the strongest economy in the world is if we work together. I know that we're under an expedited timeline looking at 5G type capabilities, but the reality is where we're going in the future, we're autonomous vehicles, unmanned systems, autonomous logistics, autonomous farming, all those components tell us our discrete assignment process is no longer valid. And in order to support those future technologies, we have to look at how do we provide wideband type communications across all our operations, whether it's commercial or the federal government or the Department of Defense. So we have to apply those type of capabilities and work together to get there. Now, my recommendation to leadership is spectrum modernization is key to success, but this doesn't stop here. We need senior leadership engaged in understanding. And I realize when we talk spectrum management isn't sexy. It's just not frequency assignments, and it's just not frequency certification. And I know that's the key context when you look at senior leadership. We're talking about frequency assignments, and that's French. We shouldn't have this discussion. I believe it's more than certification. It's equivalent to IEEE standards. A lot of those components and changing that mindset and culture is important to us delivering key capabilities as we move forward. Spectrum ownership to a full sharing environment really is the next step of evolution. And if we really want to lead technology evolution, that is how we get there. Bandwidth on demand, that's the key component. As I like to say, all the elements of discrete frequency assignment processes do not provide bandwidth on demand or communications on demand, and it should be available full time when we want it and when we need it. When I want to talk to my family on FaceTime, it should be available. When I want to sit there and watch a YouTube video, it should be available. When I want to get out there and traverse any future social media type content, it should be available. I shouldn't have to request permission to get access to something that's available to the American people. Integrate security end to end. I can't stress that enough, because without protecting our innovation and protecting our communications, those key pieces work hand in hand. So I look forward to the future collaboration as we start to move forward. And I know that I said a lot over the last few minutes, and I look forward. And once again, fair winds and falling seas to Tom Kidd. He's been an inspiration to the entire organization. And I know his out-the-box thinking was sometimes frowned upon from a military standpoint, because a lot of the reason how we came to these conclusions is him thinking outside of the box and forcing us to move on. Thank you. Any questions?
Great. Thank you very much, Art. That's, there's a lot going on, obviously, and you crisply stated some of the three conclusions about, the full sharing environment, bandwidth on demand, and, integrated security end to end. Are you seeing anything with, let's say, near peer competitors in this area, and is that part of your research?
So I know that we recently started to have that discussion. What are the near peer competitors and how do we really look at whose product provides the best capability? And I know some of the key context and how we look at it. What is that supply chain component? How do we integrate and ensure that we're protecting our operations as we start to look at interfacing and leveraging this technology? I know the department has started and begun leveraging that technology, and some of that supply chain to start off with has really created a delay in our ability to deliver capabilities to the installation.
And with supply chain, I know we know that, for example, Shanghai, 400 million people are locked down with equipment and all kinds of other components, chips. We know that, I guess, we're reshoring a lot of chips, trying to make sure we kind of have our own fences around our own chip foundries to some extent. Is that part of your analysis when you look at how to get spectrum groomed and utilized?
I would say that has to 100% be part of the analysis. The foundation of some of those old components that we started to outsource to other countries because it was cheaper and least expensive. And I have to say, I remember the days of building inductors for the space shuttle at our DeLeon facility in Denver, Colorado, and doing a lot of that production internal to the United States. I think it's evident based on the supply issues that we're having that we have to start considering how we integrate that into our future platforms. That assures that we're not building viruses or other integrated type capabilities that may affect our systems in the future.
Thanks for that. Now, on the 1.4% spectrum still exclusively held in the DoD space, and then the 5.6, I guess, exclusively held or utilized in the commercial space, and the goal of getting to 100% sharing. Is there any case that you're bumping into for keeping some exclusivity?
I know that that's always going to be the case from a Department of Defense standpoint, and that's part of the change is hard, and a clear roadmap and strategy, excuse me, strategy to get there is going to be important. I know there's some key areas that are hard. Sorry. Some key areas that are very difficult when you talk about that full sharing capability. But what are those aspects and what are the key capabilities that we have to address to get there? I think we're already looking at some of the larger issues. The larger issues that create large problems are radar capabilities that put out 1,000 watts and pulse and talk 360 degrees. Of course, some of the C-band issues that we have encountered looking at FAA and protection of national airspace type capabilities. I see those as continuing to be challenges, but I think if we work together and learn how we use our same receivers to support or supporting versus supported type concepts, we may have a better method of how do we not only look at the defense component or the federal government requirements for national airspace, but also consider how do we share better. And the best way I could describe it is for AWS-1, I know we had these indefinite protection zones around Cherry Point, North Carolina, and Yuma, Arizona, but the technology had advanced so rapidly that we set up some testing procedures there at Cherry Point, North Carolina, and we came up with a design that essentially eliminated that 100-mile radius protection zone that we originally started back in AWS-1. And now the cellular providers can deploy all the way to the installation without causing interference to our operations and vice versa. And like anything else, when we first drew that conclusion, we hit a few road bumps, but we easily migrated, coordinated together, and came up with the solution. And now it's still working today. So this occurred on 2016, still no problems as far as our sharing agreements and how we're working it. So I think that's foundational and talks that we're willing to think outside the box and work towards those procedures.
That's great. Testing is near and dear to NSMA's heart. The more physical tests, the better. We always know that when things get mapped out on a laptop or in a database, there's always useful information, but it's not a full substitute for full-on testing because there's usually some sort of anomaly or some Murphy's Law aspect to it. Measuring twice and cutting once often includes, if not always, good physical tests. And I guess with that in mind, with the additional spectrum, the 1.4 and the 5.6, since they're not overlapped, so that adds up to 7% of the spectrum out there still needing to be brought into the full sharing environment. We've had some discussions on and off about maybe having more aggressive testing labs, outdoor spaces like INL, Idaho National Labs. You mentioned Cherry Point. I'm sure there's others. And that usually is driven by having more test engineers, spectrum managers who can be at the helm to help put those tests through their paces using good industry standard and mil-spec guidelines. So with, I guess, with that in mind, is there any recruitment going on when it comes to folks who can do those kinds of tests? Are you resourced well, or do you need more resources? What are you seeing?
I know from a headquarters standpoint, I know there's limits to how we can be resourced and the amount of personnel that a headquarters can carry. So from that aspect, it's more of a partnership when we look at how do we hit these large strategies and work together to support these type of requirements. And typically, it's us working with the U.S. Navy and the U.S. Marine Corps and leveraging their manpower to work as a whole to attack large problems like this. And I would say that Mr. Mann's testimony to the House recently talks to a lot of the key capabilities that we are starting to see. Some of our aging infrastructure within our research and development components are in need for replacement. And those key components are somewhat how do we protect and keep talent, supporting the Department of Defense and looking at new strategies to share. And I think that's some of the area that we're going to be looking to try to improve to ensure that we do have the ability to do the research and development and be an economy of choice when we look at how do we share better with the federal government and industry as a whole.
That's great. I know industry is always enthusiastic about sharing with the DoD sector and also supplying prospective solutions. We like to be supportive, of course. We had some talks yesterday, including one from John Pelson about making sure that our U.S. based operators and U.S. based manufacturers are fully on board and not too overlapped with near peer competitors. So that's another area of deep concern, and we're concerned about China and things like that. Obviously, China supplies a lot of useful parts and technology to the U.S., but there are limits, of course, for having our own ships, having our own aircraft, and having our own spectrum technology. That's ours and ours alone. Yeah, any thoughts on that?
In fact, it automatically brings me to the China to 5G Act. When I look at some of those key elements and some of the chip technology, I would say a large portion of that chip technology and those key capabilities that are being utilized in China were developed in the United States. So that foundation alone tells me that the academia, all the key leaders within the telecommunication world is resident here within the United States. But that foundation is how do we protect our data and ensure that it's our innovation and a lot of the key components are not being lost. That key question with key competitor, I think some recent articles that I've read with China integrating to some of our academia institutes and utilizing that as a method to leverage or pull US type innovation out of the US and directly tied to China is some of the other key areas that I see where we protect our innovation and ensure that we're planning for the future.
Well said, well said. I don't see any additional questions. The reason I'm looking at my phone is Mariana will text me if there's questions. I'm not playing video games, but I think we've hit the ceiling. Any other thoughts before we close out?
No, Joe, I think like anything else, when Tom Kitt, tough act to follow. A lot of great insight and a lot of great innovation, especially when he looks at power beaming of wireless type power. I mean, that's going to be a key element as we move forward. But as he stated, is how do we really consider the radio regulations to support power beaming of power down to the ground, and then seeing the earlier meeting with RF human exposure, automatically that comes to mind because that's going to be one of the key aspects that we look at is RF exposure anytime that we discuss beaming of power from space-based systems down to the United States or anywhere in the world. But it's been an absolute pleasure, and thank you for having me.
It's a pleasure to have you. We always appreciate the Navy, appreciate your insights, and always welcome here at NSMA. You always have a home. We'll have our next panel in, I guess, about 12 minutes or so, and look forward to that as well. Thanks again, Art. Well,
Thanks, Joe.
okay.